Hey everyone, this is a video for honors for Unit 10, Section 2, Part 2. So this is part of Week 2, so don't think, wait a minute, I already did this, I'm on the wrong video. No, that's fine. So we are on our Section 2 notes, which look like these, where we were talking about KEQ, or equilibrium constant. So a KEQ value is basically just a constant that essentially tells us whether or not the reaction is going to favor the reactants or the products, i.e., are we going to see a concentration of reactants higher or a concentration of products higher, okay? So that is what a KEQ value is. So we said equilibrium means that the rate of the forward reaction and the rate of the reverse reaction are the same. That does not mean that their concentrations are the same. So what KEQ is telling us is saying, okay, well, no matter what concentration we start with, are we going to end up with a concentration higher for reactants or a concentration higher for products? So that's what KEQ is, okay? Now, obviously not something you need to memorize in detail. I put over here that a KEQ of right at 1 means that it really isn't favoring either direction. So in that case, the rates and the concentrations of the products and the reactants would be the same. But in most reactions, we're going to see KEQs that are either greater than, significantly greater than, or significantly less than 1. Significantly greater than 1 means that we're going to have a higher concentration of products. KEQ less than 1 means that we're going to have a concentration of reactants that is higher than the concentration of products. Okay, so we saw last time how we can set up problems to calculate that, and we saw that this is the basic idea here. So we have KEQ, we take all 4 of the parts of the equation. I don't know why my hand's shaking, but you get the idea, too much coffee. The 4 parts of the equation, or the parts of the equation, the products are on the top, the reactants are on the bottom. A couple rules there is if something has a coefficient, we make it an exponent on that particular concentration. And second thing is, and this is something a lot of us missed, and so I want to make sure you check this, states of matter matter. It just is what it is. Chemistry wouldn't be chemistry if there wasn't these rules that didn't seem to have a reason, right? So the rule is only gases and aqueous solutions can be included. So on the practice, a couple of you had some errors in numbers or in letters E and G, because E has H2O as a liquid, G has carbon as a solid. Both of those need to be excluded from their expressions, okay? So I wrote on here the expression for the first one. So HCl was the product, so it gets squared because it had a 2 in front of it, and then it is divided by the concentration of the 2 reactants. Now, we are going to move to the next page, the page that says "want to get ahead," which yours doesn't say that, but mine does, because this was a paper I was using a week or 2 ago, okay? So what we're going to be looking at now, so flip over to that page. So now we're actually being given concentrations of the particular substances. So instead of just saying arbitrarily, oh, it's the concentration of the HCl, now we actually have concentrations. So with that expression, in the problem it says that the concentration of hydrogen gas is 1.0 times 10 to the negative 2, chlorine is also 1.0 times 10 to the negative 2, and HCl is 1.0 times 10 to the negative 4th. Okay, so again, the sum of the other 2 is then multiplied, just like with KW, if you're connecting back to that. All right, so the concentration of HCl, it says, is 1.0 times 10 to the negative 4th molar, and then that is squared, okay? So I squared that because that has a 2 in front of it in the equation, so again, it's in the expression, it's squared, so I'm going to square it, okay? All right, and then I'm going to divide that by 1.0 times 10 to the negative 2, which is the concentration of hydrogen, and 1.0 times 10 to the negative 2 again, because that is the concentration of the chlorine. And of course, I brought everything over here except for my calculator. Hold on. Where's my calculator? Where's my calculator? Where's my calculator? I found it. All right, so I'm going to take 1 times 10 to the negative 4th, and then I'm going to divide that, but I'm going to put that in bottom end parentheses because I want to make sure that 1.0 to the negative 2. So this is how I put it in my calculator. I'm not sure if you 100% can't see that. Okay, cool. Oh, no. Okay, all right. So I put 1.0 times 10 to the negative 4th divided by, and then open parentheses, 1.0 times 10 to the negative 2 times 1.0 times 10 to the negative 2. So I get a value of 1. I got a value of 1. Since it's a constant, it doesn't need any sort of unit. Now, when we do a KEQ value, again, it's trying to tell us whether this reaction is product favored or reactant favored. So we want to make sure we actually identify that. So something with a KEQ of 1 means that this substance has no favoring, which means at equilibrium, the concentration of the products will be equal to the concentration of the reactants. Now, again, we said that's not always how it's going to be, but in this particular instance, that is what happens. If you end up with a KEQ of 1, that means that not only are the rates the same, but the concentrations are also the same, okay? Now, I'm going to do another practice on this. Hopefully my video doesn't freeze and cut off like last time, but we'll see. So I'm gonna do part B. So the equation there, see, I'm not gonna edit these videos down. You guys need to see the realism of this, right? Because this is what you see in the classroom. We ain't trying to hide anything. So the equation here is 2CO as a gas plus oxygen gas makes CO2, and there's 2 of them, and that is also a gas. Okay, so we have that equation, and so that's the equation for the second expression on the second page of your notes, but also on the third page of your notes, it's the next one. All right, so I'm going to take the concentration. So again, KEQ, so the products, bracket CO2, and that is squared, and then bracket CO, and that is also squared, and then bracket O2. Okay, so this is the expression I'm going to use. So if it cuts off, just know that this is as far as I got, and then I put in the numbers, multiplied, divided, etc. Okay, so you are going to, again, KEQ equals concentration of carbon dioxide is 3.2 times 10 to the negative second molar. And again, molarity is concentration, so molar indicates to us that we're talking about a concentration. Divide, oh, and that's going to be squared, divided by 2.5 times 10 to the negative third squared, and 1.6 times 10 to the negative third. Okay, so this is how I have it set up right now. I have the 3.2, which is the numerator, and that's going to be squared. And then I have the 2.5 times 10 to the negative third, and the bottom, that's also going to be squared. And then the last one is not going to be squared. The reason it's not going to be squared is because if you look back at the equation in orange, which is hard to see, but you get the idea, there's not a 2 in front of it. So with no coefficient, it doesn't get squared. All right. If the coefficient was a 3, then it would be cubed. If the coefficient was a 4, then it would be quadded, raised to the power of 4. So I am realizing that I'm pretty sure I had a pretty nasty error on the paper over there. So those of you that got ahead, if you were like, that's not what I got, that's probably why. All right, so I'm going to square the numerator, and then we're going to divide that. All right, 3.2 times 10 to the negative 2. That's going to be squared. And then divided by parentheses 2.5 times 10 to the negative 2 squared. All right, I'm having some calculator issues, but you get the idea, okay? So 3.2 times 10 to the negative 2, and I'm going to square that, divided by, let me do double parentheses, there we go, 2.5 times 10 to the negative third squared. Times 1.6 times 10 to the negative third, not squared. Perfect. Okay, so the value I got, which seems a little high, but maybe that's just me, is a KEQ value of 102,400. That's 102,400. It's a relatively high value. So what that indicates to me is that since it is a value that is greater than 1, we are expecting the products to be favored here. So anytime carbon monoxide and oxygen get together, we are more likely going to create CO2 than anything else. So because this value equals greater than 1, we can expect that this is going to be product favored, which means the concentration of the products are going to be greater than the concentration, all of a sudden I'm from like Boston, is going to be greater than the concentration of the reactant. So we would see it shifted in that direction, okay? So I want you to continue those couple practice problems right there. And then I am going to be, you don't need to submit this, but I want you to practice these. And then I'm going to be posting a sheet that I can't remember if you already got or not. So you'll find out in a little bit if you already got it. If you already got it, great. If you did not already get it, then you'll just be able to print it out, or you can just do it on a separate sheet of paper. I don't particularly care either way. Whatever works for you. Obviously, it's best if you can print it out, but if you don't have a printer at home, or if your ink is weird, or blah, 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 whatever, because home printers suck usually, it's okay if you need to just do it on a separate sheet of paper. But do what is actually best if you have that option, okay? All right, so that is the end of the lesson for Section 2, Part 2, Week 2, okay? And then what I want you to do is you can do the practice on the practice sheet that I'm going to post right underneath this for this particular section. Then go ahead and watch the video for Section 3 and do the practice for that, and then you'll submit it together, okay? And I will clarify in the later videos what we're doing all this week. All right.